Good evening, everyone. It is Sunday, April 24th. We are holding right now, first of all, it's one day after Passover. I've also become aware that part of the audience, perhaps even a significant number of the audience of this podcast, is currently involved in a 40-day religious fast, and I want to wish all of you an easy fast. You look at the heat index. The National Weather Service has a heat index chart. The heat index was 91 degrees at the time that the temperature was 96 degrees. I don't have the information for what the heat index was or the dew point at the time the temperature was 97 degrees, but the heat index was 91 degrees. That's because a dew point of 31 degrees, when the temperature is 96 degrees, the evaporative cooling is extremely intense because there's enormous amounts of evaporation that's taking place because the air is so dry. Therefore, the temperatures actually feel cooler than what a normal 96 degrees would feel like. Now, we mentioned, however, there's another component to this, and I wanted to explain this. We explained that when there's strong winds, especially when you get to 30, 35 miles per hour, those types of winds, if you're on a motorcycle, you're going to feel this, especially in the Phoenix, Arizona area. Cyclists, they know this to be true, those that ride motorcycles, that it's much hotter. It's much hotter in the wind when it's brutally hot. When temperatures are above 95 degrees, it gets hotter. The question is why? Why does the wind always makes a person feel colder? But when the temperature is 95 degrees or warmer, the wind makes a person feel hotter. And why is that? And I'm going to explain right now that I believe there's two reasons for this. Number one, the reason wind makes you feel cooler, one reason, is because it blows your body heat away. Now, your body temperature is 98.6 degrees. So, in theory, let's say, if the temperature is 98.6 degrees out, let's say it's 99 degrees out, so the wind is no longer blowing your body heat away. It's actually blowing suffocating heat in your face. But if that's the case, the question is, how come the wind starts to make conditions feel hotter already at 95 degrees? And the answer to that is because it doesn't have to do with your internal body temperature. It has to do with your skin surface temperature, which is about 95 degrees. So when the temperature is 95 degrees, a wind comes, it makes it feel hotter. That at least that component of blowing the body heat away is no longer taking shape over there. That doesn't happen anymore because it's no longer blowing the body heat away. But there's a much more significant cooling effect that happens due to the wind blowing, and that's called evaporative cooling. Your body sweats, and the process of the evaporation of the sweat cools your body off. That's the natural air conditioner. It's when that's when the energy of the temperature, those temperatures go down because the energy gets transferred into the evaporation process. Evaporating the sweat requires energy, and it robs the air of its heat. So the temperatures go down, and it makes you feel cooler. Now, but if it is so hot and it is so dry that the evaporation is taking place so quickly that you don't even have a chance to get wet. There's not even a chance to get wet. So then the natural air conditioning system of the body completely shuts down, just like it does in humid air, which is amazing. In humid air, because it's so humid, the evaporation rate goes way down. So the body no longer has an effective natural air conditioner. The body doesn't have a way to cool itself off because the sweat's not evaporating in an efficient way. So the temperatures feel much warmer. It's very similar when it's hot and dry and windy. If it should be humid out, interestingly enough, if it's humid out and it's 95 degrees, the wind will make it feel cooler because the evaporation rate is not intense enough to completely dry you. You will still feel sweat. As long as you still feel sweat, the wind will be effective at cooling things off. So if there's high humidity, however, eventually, even with high humidity, eventually the wind will make conditions feel hotter, even when there's high humidity. It just doesn't happen at 95 degrees. It's going to happen probably closer to 98 or 99 degrees. In North Platte, Nebraska, the relative humidity was 10%. I don't even know why people talk about relative humidity, because the main thing is the dew point. The dew point was 31 degrees. This is super dry stuff, the type of stuff that occurs in Death Valley, California. It was super dry. The evaporation rate had to have been very, very high. I wasn't there. I wonder what people have to say about what happened on Friday out there. The sun was not out. If the sun was out, that makes temperature feel approximately another 15 degrees warmer, says the National Weather Service. It was mostly cloudy. I don't know how thick the clouds were. I don't know how thin the clouds were. I didn't look it up. But those were two reasons why conditions feel hotter when the wind is blowing. The wind will actually make it feel hotter. Not just hotter, it's actually a suffocating heat. There's certain races they have in Kansas, and there are times when there's heat illness and different things that take place in these bike racing and motorcycle racing races, and the times when the illness reaches its peak is days which are windy, not days with high humidity. Kansas fluctuates between the dry and wet line. That's the dry line when you have warm, moist air coming off the Gulf of Mexico from the southeast flow, and then you have southwest hot, dry desert air, and they run into each other. That creates a front. It's the dry front. That's what we had in Nebraska on Friday. Thank you all for listening. I wish you all a great night and a great week. And to those of my fan club that are fasting tomorrow, have an easy fast.